We're going to travel around the world a fair distance now over to the US, and Dr. Johnson's going to talk to us about some implants for beef cattle.
Well, good afternoon, and like our previous speakers, I want to thank Biomin for the invitation, particularly Brian Miller and Ruben Beltran from the U.S. But I also want to point out the level of organization of this meeting. I've given many international talks throughout my career, and working with Eva Binder and Ying Zhang on the organization of the proceedings and travel has been unprecedented. So I applaud Biomin for the effort put forth in this international convention or congress. Like some of the previous speakers, I'm gonna take more of a geographical approach in some ways in talking about very specific beef management practices in the U.S., specifically at the feedlot level. And recognizing a speaker this morning talked about how we have to be cognizant of geographical differences as we talk about different practices, and not all practices can be applied to other geographical areas. However, much of what I'll talk about, I think, could very much be applied globally. And in fact, I've worked in places like Brazil and Indonesia and South Korea, where many of the things I'll talk about this afternoon can be applied very effectively to increase global beef production. So from a United States perspective, we have many different objectives of our beef industry, and I was at a congress a few months ago where somebody complained, a friend from another country complained that the U.S. beef industry is very mature, and in fact we maybe are mature, but hopefully we have led the way in many of both the productivity improvements as well as the efficiency improvements. But I still think there's a lot of improvement to be gained in the United States beef industry. Some of our objectives over the years is we've kind of split it into two different areas. We're very interested in growth, and in fact I call that productivity. We've had phenomenal gains in productivity in the United States beef feedlot industry, and one of our best markers of that is average daily gain. We also have led the way in efficiency, and I really appreciate the whole concept of sustainability at this conference. And I think one of the best benchmarks of that is feed efficiency or efficiency. We've made great strides just in the last 20 years of improving feed efficiency in ruminant animals on the beef feedlot side in the U.S. And of course, part of this is we've learned, and much of what I'll talk about, I'm trained as a muscle biologist, a muscle growth person. When you talk about feed efficiency in meat animals, when you increase the lean to fat ratio or you increase muscle deposition, you're naturally going to improve feed efficiency because of the caloric differences in those two tissues. So we've kind of selected animals for high muscle to fat ratio. However, in the U.S., we've taken pride in high quality beef. And so sometimes these can be antagonistic to each other. We try to improve growth rate and efficiency of growth, but at the same time, we're very interested in beef quality and those palatability factors like tenderness, juiciness, and flavor. We take much pride in the U.S. of producing not like Japanese Wagyu beef, but middle-of-the-road marbled beef that is really accepted worldwide in many circles. And so we want improved marbling with very minimal subcutaneous fat, and we also want that product to be very tender. So again, we're often, as animal scientists or beef production people in the U.S., we're pushed at two ends of the spectrum. We want lean, efficient animals, but we want very high quality, high marbled beef. And so that can cause some issues within our industry. Now, if we just look, and these are not current, but they're following very similar trends to what we have in the U.S. beef feedlot system. If you just look at steer hot carcass weights as well as heifers, we're at unprecedented levels in hot carcass weight. And I apologize, these are in pounds, but you can see over the last 10 years, we've steadily increased hot carcass weight. And in fact, that has continued to go up in the last 3 or 4 years. And in part, there's a lot of reasons for that. We can talk about genetics of the animal, the nutrition of the animal, but more importantly, what I'll talk a lot about this afternoon is the use of growth promotants, namely implants and beta-agonists in the U.S. to increase these hot carcass weights. And interestingly, as I talk, there's an antagonistic effect. As we increase hot carcass weight, most of that thought to be lean tissue, we tend to reduce the percentage of cattle that grade choice. And U.S. choice would, again, the two main factors affecting quality grade in the U.S. are maturity and marbling score. So if we're feeding young cattle, really the only factor to affect this is marbling score. So you can see that we gradually decrease marbling score, but now more recently we've seen an upswing of marbling score even in light of heavier hot carcass weights. So what I hope to do in the short time this afternoon is I'm going to talk specifically about some of the management tools and predominantly growth promotants that have been used in the U.S. for the last 60 years to improve both rate of gain, efficiency of growth, and then also try to leave a little bit of time at the end to talk about some new, what I call new frontiers in beef cattle production practices in the U.S. So again, as a previous speaker talked about, as Dr. Lean talked, I won't spend a lot of time on this, and this slide has a lot of numbers, but what I want to point out is that for now 60 years, so 60 years ago, we had our first growth promotant approval by the US FDA in 1954. So we have been implementing exogenous growth promotant technologies in the United States now for 60 years. And again, you know, as we talk about activism versus science, I always like to bring this up, that if there was an overarching problem with residues or anything else, that in a 60-year period, I think we would start to see some of these issues arise from consumption of that product. The final one, and I'll end my discussion talking about beta-agonists this afternoon, kind of our last approval from a growth-enhancing standpoint in the U.S. occurred in 2006 with a beta-agonist called zilpaterol hydrochloride, marketed as Zilmax. So real quickly, and Dr. Lean already went over this, we can classify steroid hormones really in 3 different categories. And in the estrogenic or the female hormones, of course, the natural one is estradiol 17 beta, that all of us in the room also possess the same hormone. The infamous synthetic one that was taken off the market in the U.S. in the 70s due to the Delaney Amendment was diethylstilbestrol, or DES. And as we've had several discussions already on Zeranol or Ralgro, that's what I call an estrogen-like molecule coming from corn mold. On the androgenic or the male side, of course, the natural one is testosterone propionate. The one that I really think revolutionized the beef industry worldwide, especially in the U.S. from an implant standpoint, was the synthetic androgen trenbolone acetate that was approved in 1987 in the U.S. and then later combined with an estrogen in 1991. The first company to market that was now the Merck Animal Health Company, and that product was Revelor. We also have a product or products approved in the U.S. That are progestins, and these are actually orally active feed additives. And of course, we know the natural progesterone of the hormone of pregnancy is progesterone, and the synthetic product that was approved in the late 1960s to suppress estrus in feedlot heifers is melangestrol acetate. We've later found that MGA in feedlot heifers can have what we call a hyperestrogenic effect, where in fact it mimics growth promotion by increasing the natural ways of producing more estrogen in the heifer and improving growth rate. So again, roughly over 90% of our cattle in the United States, and as I talk about North America, it'd be the same in Mexico and Canada, a very high percentage, at least in the United States, greater than 90% of the cattle at some point in their lifetime receive an implant. And again, most of the steroids that we've shown on the previous slides are put into compressed pellets and implanted in the back of the ear, and these implants then dissolve over time. The active ingredients will circulate into the bloodstream and then elicit some sort of either endocrine response or some local response on muscle growth. So again, for over 25 years, I've worked on growth promotion techniques in beef cattle. And in fact, one of the hallmarks of using these growth promoting techniques is we are going to increase lean tissue deposition in cattle. And some of the early work I did with an implant, the combined TBA E2 implant, we showed a nice increase with the Revelor S, 120 milligrams of trenbolone acetate and 24 milligrams of estradiol 17 beta. We saw a nice increase in carcass protein deposition with a single implant compared to non-implanted controls. So we're going to increase protein deposition or lean tissue deposition, at the same time improving feed efficiency as well as productivity at like average daily gain. And subsequently, we've went on to do many mechanistic studies in our lab and other labs that I collaborate with worldwide to show that, in fact, these steroids have a very specific effect at causing an increase in the proliferation and fusion of very specialized muscle cells called satellite cells that then enter the fiber and help support this postnatal muscle growth. So we've done many mechanistic studies to really show how these steroids work at a cellular level to improve feed efficiency in beef cattle. And in fact, what happens with implants, we've done cell culture models like I've showed on the previous slide. Outside of the muscle fiber, we have very specialized cells called satellite cells that are available postnatally, and these cells are able to divide yet, but ultimately what they want to do is they want to fuse into the existing fibers to support muscle hypertrophy. And in fact, the active ingredients in the implants aid in the proliferation and fusion of these cells into the existing fiber. I now want to switch to a much more controversial subject, at least in the United States the last 14 months, and that is the beta-adrenergic agonists as a class of growth promotants that will stimulate beef cattle growth and muscle development as well. Now, the beta-agonists have been around for many years, and many different companies in the late 70s were very interested in looking at beta-adrenergic agonists as a way to stimulate muscle growth and reduce fat or adipose tissue accretion. And we have two of them approved in the United States, and in fact, just within the last few months, we had another class of beta-agonists approved in South Africa. Our salbutamol that I don't have on this list was just recently approved in South Africa to be fed to feedlot cattle. The two that are approved in the US are ractopamine and zilpaterol. Now, ractopamine is also approved for two other species in the US in addition to cattle. The first approval of ractopamine in the US came for swine as Paline, and then the cattle product is called Optiplex, and just a few years ago, Topflex was approved for turkeys in the US. And in the US, zilpaterol is approved as Zilmax and marketed as Zilmax worldwide. The first country to approve Zilmax for cattle was actually South Africa in the late 1990s, and then Mexico was second, and the US approved it, as I said before, in 2006. Quickly, I want to point out that all these compounds, beta-adrenergic agonists, are classified chemically as phenolethanolamines, in that they possess three key components to that structure: a phenol group, an ethanol group, and an amine group. And so that's very important from a ligand specificity standpoint as they bind to beta-adrenergic receptors. And in fact, beta-agonists do bind to naturally occurring beta receptors. They bind to the exact same receptors as the natural catecholamines that we all have in our bodies, epinephrine and norepinephrine. So those also are phenolethanolamines. They're considered catecholamines that are important in physiology, and they bind to the same beta receptors. We recognize three different subtypes of beta receptors: beta 1, beta 2, and beta 3. And not to spend a lot of time on this, but upon ligand activation, these are G-coupled GPRs, G protein receptors that are coupled to a G coupling protein, and that G protein is going to activate a very important enzyme, adenylate cyclase, that increases cyclic AMP levels, And cyclic AMP is considered a second messenger, which is going to increase the activity of protein kinase A, and then we're going to have a whole cascade of events that occur. The bottom line is most people would generalize that beta agonists activating the beta receptors by binding of a beta agonist is going to increase protein synthesis at the skeletal muscle level, reduce protein degradation, and will actually have opposite effects on stored adipose tissue, where we increase the rate of lipolysis and reduce the rate of lipogenesis. We've done recently a lot of work at quantifying and characterizing different beta receptors in bovine skeletal muscle. And in fact, we have some immunohistochemistry techniques where we've identified all three of the beta receptors in adult bovine muscle fibers. And so we're very, very excited that these beta receptors are prevalent and biologically active in skeletal muscle. So real quickly, I want to give you kind of an overview of what to expect by feeding these different beta agonists, at least from a North American beef perspective, what the level of response would be at least in castrated steers. So we have two products that are approved. I talked about Zilmax and then Optiplex, which is ractopamine. Zilmax is zilpaterol. Zilmax was approved at a single dose. We can only feed a single dose of Zilmax at 8.3 part per million of dry feed, which if most of our cattle in the U.S. eat 10 kilograms, they're consuming about 80 to 90 milligrams per head per day of zilpaterol. Now, and it can be fed for 20 to 40 days, but the FDA put in a 3-day withdrawal from a residue protection standpoint. On the Optiplex side, ractopamine can be fed over a multiple dosage. We're anywhere from 100 to 430 milligrams per head per day, and it can be fed for 28 to 42 days, the last 28 to 42 days, and there is no withdrawal on this particular product. What's interesting, if you just look at live weight response at the end of the feeding period, we get about a little over 8 kilograms of live gain with Zilmax, and then depending on the dose of Optiplex, we can get a very similar live weight response with a higher dose of Optiplex compared to Zilmax. But what's interesting is that the Zilmax gives us a very interesting phenomenon from a carcass gain standpoint. Remember the previous slide, we only had about 8 kilograms of live weight gain, but on the carcass side, we get more carcass gain than live gain. And we'll get close to 33 pounds or 15 kilograms of carcass gain by feeding Zilmax for 20 days. And so in fact, what we're doing is we're obviously shrinking or taking away some non-carcass component and allowing that energy to be diverted very quickly to muscle growth or tissue gain of the carcass. This is a very consistent response that we've observed with zilpaterol. Now with Optiplex, we always are going to get less carcass gain than we get live gain. But as we, interestingly, recently we've done some 400 milligram studies with Optiplex, and we've gotten well over 12 kilograms of carcass gain. So as we increase the dose of Optiplex, we will increase carcass growth. Another very important profit parameter in the U.S. cattle feeding business is dressing percent or carcass yield. With so many of our animals now being sold on a grid or a carcass basis, dressing percentage is very important. And so Zilmax very consistently would increase yield percentage about 1.5 percentage units. So in the U.S., a typical yield with an animal not fed a beta agonist is maybe like 63.5%. So if we're putting in a beta agonist, we're going to get close to 65%. And Optiplex, you can see, is a little bit less, but it is very much a dose titratable event. And finally, these products do very much have a specific effect on ribeye size or muscle growth. You can see that Zilmax, for example, will increase the size of the ribeye area about 1.5 square inches. Optiplex is less, but again, as we increase dose, we're going to get more of that muscle effect. And in fact, we've done also a lot of work at the mechanistic level with these beta agonists for skeletal muscle growth. And unlike steroids that will increase these satellite cells, the beta agonists do not do that. and in fact have very specific effects on protein synthesis and protein degradation. Now, some of those effects can have negative impacts and on tenderness, as a previous speaker talked about. And in fact, those are very real effects to reduce these particular tenderness issues. And again, we've used some of our immunohistochemistry techniques to show that at least Zilmax will increase the diameter of these muscle fibers very consistently. And this is one of the mode of actions of how these beta agonists increase lean tissue deposition. Real quickly, in the US, obviously it's very common to combine these technologies. So early on, we've had implants now for 60 years, but we'd had implants for almost 50 years before beta agonists had ever been approved. And so I often wondered, before the approval of the first beta agonist for cattle, would these act additively? Or, in fact, would we have some sort of interaction where if we're already using an implant, like we have on the top line, when we bring in the beta agonist, we're not going to get any more growth? And so that was always a question in the back of my mind. We have aggressive implant strategies in the US. Will these work? Will they be additive, where 1 + 1 = 2? Will they be somehow synergistic, where we get more of an effect? Or will we have some sort of negative interaction where we get less of an effect? And we've been involved in many different trials, and in fact, they're truly additive, completely additive. Whatever we get from the implants, and you can see in this first trial that we published for additivity between Revelor implants and Zilpaterol, you can see that a single implant gave us a nice 25-pound carcass weight response, and Zilpaterol gave us a huge 40-some pound response, but when we added the two technologies together, we got 70 pounds of hot carcass weight. So in fact, they're truly additive when we use them, and suggest they work through independent mechanisms. So to wrap up, I want to talk about some new areas. And I think this is where some of the products that Biomin would potentially fit. We have a huge issue that has just evolved in the last 18 months in the United States. And we have a particular class of cattle, calf-fed Holstein steers, which account for almost 15% of our cattle on feed, because we only have 89 million head of cattle now in the United States, where we've seen a dramatic increase in liver abscesses. So typically, in a Texas Panhandle feedlot or a Southwest Kansas feedlot, they would feed tylosin, the antibiotic tylosin, to prevent liver abscesses, and in fact might see 10 to 12% liver abscesses. And these calf-fed Holsteins being fed in the Texas Panhandle and Southwest Kansas, we now have reports of pens of 100% liver abscesses. And this is in light of tylosin feeding. Other interesting aspect is, many of you, if you follow the US legislation, FDA has now instigated that Thailand falls under the Feed Additive Act, and in fact will have to be scripted by a veterinarian in the very near future. So the tylosin has brought about some pressures, and because these cattle were fed Thailand, the first thing people thought of was antimicrobial resistance, and in fact other people have ruled that out. In fact, we've taken samples in some of these calf-fed Holsteins, and this picture probably is very graphic. They're the size of a volleyball, the abscesses. And we've identified two very novel bacteria from those abscesses, and are consequently looking at natural interventions to potentially block the invasion of those very strict anaerobic bacteria that cause these abscesses. I think essential oils hold the key. In fact, there's a publication in the Journal of Animal Science by the University of Nebraska showing essential oils had very positive effects on liver abscesses. We've also done a lot of work in our lab with yeast and yeast cell wall products, and I think certain trace minerals could also help this. And I think combined together, the three of these may be our best chance to eliminate this emerging problem in the US side. Here's some pictures that we've generated over the years showing live yeast and yeast cell wall products' ability to bind certain different bacteria. This happens to be Fusobacterium, which is the main causative agent of liver abscesses, and this is our Canobacter. Some other natural alternatives. Our lab has interest in both chromium and zinc's ability to affect both muscle growth as well as marbling development in cattle. And we're going to continue down that road. And also, I think encapsulated amino acids and protected fatty acids offer an avenue to improve efficiency in a natural way and also improve meat quality. So to conclude, again, from a United States or a North American perspective, growth promoting usage results in rapid biological responses at the skeletal muscle level. And as I said before, over 90% of our cattle at some point in their life receive an implant. From a beta-agonist perspective, up until what happened 13 months ago with the suspension of Zilmax sales, we had about 75% of the cattle in the U.S. being fed a beta-agonist at the end of the feeding period. All these fiber types seem to have increased muscle hypertrophy, and again, this can have negative effects on marbling and tenderness. Kind of the bottom line, as we talk about sustainability, like the whole theme of this conference, I really think that growth promotants still fit in that globally and are very vital for sustainable beef production. In addition to being approved in North America, for example, Optiplex is approved in many places other than in North America. For example, Indonesia, Optiplex is approved for cattle feed in Indonesia. And implants are approved in many different countries as well. And I still think that has a place for sustainable beef production globally. Interestingly, both beta-agonists have been approved in Brazil. Ractopamine and Zilpaterol are both approved in Brazil but have never been marketed, in part due to some of the pressures of the European Union from the exportation of that meat to Europe. We know that these technologies aid in carcass gain during and at the end of the feeding period, but I really think that as we trend forward, we're going to have continued pressure on the use of some of these traditional growth promotants, even in the U.S., and we've started seeing the increase in the natural beef production systems even in the U.S., and I think because of that, increased interest in natural alternatives will be very, very important for the vitality and sustainability, at least of the North American beef production system. Again, in the U.S., we've gotten really good at balancing this. We're balancing productivity and efficiency against carcass quality or meat quality. And I think a lot of the things we've learned in the U.S. can be adapted globally to do that as well. So again, I appreciate the opportunity to visit with you this afternoon and would be happy to entertain any questions. So.